Welcome to this channel. In this video, we are going to discuss one IIT JEE Advanced problem from 2021. This problem is from function and its range. One function is given f of x. It is x square minus 3x minus 6 upon x square plus 2x plus 4. Now we need to decide in one interval between minus 2 and minus 1 whether function is decreasing or not, and within this function 1 to 2 function is increasing or not, function is on to or not, and the range of function whether it is within 3 by 2 minus 3 by 2 to 2. Okay, so it's a multiple choice questions, so more than one answer could be correct. So we need to understand all the choices. Okay, now how to tackle this problem I'll discuss in detail in this video. Please follow the video till the end. I hope you will get lots of information how to tackle this kind of problem, and any student who is taking preparation for JEE main or advanced, they will be able to follow this video. Okay, so don't worry, I'll discuss in detail. So let us start. So function is given here. Okay, so this is the function f of x, that is numerator it is x square minus 3x minus 6, and denominator it is x square plus 2x plus 4. Now first we should understand whether function is having any vertical asymptotes or not. What is the meaning of vertical asymptotes? So if the function is having of this form, it is rational number, something here in numerator, and if denominator is becoming 0, if this part is becoming 0, then function value will become infinite. So if denominator is becoming 0, then function will shoot off to plus infinity or minus infinity. So at particular few points we can have the function value corresponding to, so fx could be close to plus infinity or it could be minus infinity at particular points when the denominator will become 0. So those points are called vertical asymptotes at those points. So that thing we have discussed in detail in my previous video. The link will be given in the description, also at the end. So after this video you can follow that video. That is very useful one, because if you understand vertical asymptotes you can easily draw the total function f of x. Now here what is the denominator? The numerator is this one. Denominator, you can see this denominator, this function is x square plus 2x plus 4. Now this function we can rewrite as, this is x square plus 2x plus 1 plus 4. Okay, so this thing is very simply x plus 1, that's whole square. Sorry, this is your 3. Okay, this 4 I have considered 1 plus 3, so this is plus 3. Okay, so what is the meaning? That this value is always positive, not only positive, it is more than 3 always, so it is positive. So never it can be 0. So denominator cannot be 0. That implies there is no vertical asymptotes, because you can't find any point on real axis where the function will approach to plus infinity or minus infinity. That is fine. Okay, so this is one important thing. Next thing is we need to find out whether there is one horizontal asymptotes or not. Okay, so how to find these things? Now as x is approaching to infinity, I want to understand how function is varying. Okay, now what is the numerator? Numerator is these things, x square minus 3x minus 6, and denominator is this one, x square plus 2x minus 4. You can see the order, numerator of this order is 2 Again, denominator order is also 2. Same order. In this case, it's second order. Okay. So quadratic. Numerator is quadratic and denominator is also quadratic functions. Right. Now, in this case, if x is approaching to infinity, either positive infinity or negative infinity, that time only x squared will dominate. So f of infinity, if we consider, so limiting case x tends to infinity, okay, whether it's f of x, and we can see that this value will be simply the ratio of this one x squared terms, its x squared terms, because x and constant, these are negligibly small completely squared terms. So I can say that its value will be, the coefficient of x squared is 1 and coefficient of x squared in denominator is also 1, so it will become only 1. Okay, just consider the coefficient of this one and coefficient of this one, because they will dominate. Okay, rest thing we can ignore as x is infinity, approaching to infinity. Similarly, f of minus infinity, again there also, because I'll get, this is coefficient 1 and this is coefficient 1, x squared it will cancel out, so it will approach to 1. So in other words, I am saying that the function is approaching, if I have, this is the x and this is the plot f of x, we are sure that towards minus infinity the function value is 1, and towards the positive infinity the function is also towards the 1, this value is 1. So these are the horizontal asymptotes we have got, and in between the function can rise or fall. Okay, function can vary, somewhere it will increase, somewhere it can decrease, but the function value is not approaching to infinity anywhere because there is no vertical asymptotes, and the horizontal asymptotes is also finite, it is horizontal only, it is approaching to 1. Okay, so function value is having some finite range, it is not going towards infinity nowhere. Okay, I think it is absolutely clear. So towards minus infinity this function will approach to 1, towards plus infinity it is also approach to 1, just in between the function can vary. Now the next question is whether function is increasing or decreasing. How to decide these things, right? So to understand whether function is increasing or decreasing, first we need to find out the derivative of the function, means f prime x. This is d dx of f of x. If this value is positive, that time it will imply that function is increasing. Okay, and if it is negative, then the function is decreasing. Okay, and if it is 0, that time you will find the extremum, means maximum or minimum at those points. Okay, so that is very clear, because derivative positive imply that when x is increasing the function is also increasing, that's how ratio is positive. Okay, but when x is increasing but function value is reducing, is negative, that time derivative is negative, that's imply function is decreasing. Okay, at maxima or minima you will see that slope will become 0. Okay, derivative will become 0. So this is important concept that we are going to use to solve this problem. So first we will compute the derivative of this one. So function is given as x square minus 3x minus 6 upon x square plus 2x plus 4. So its derivative will compute quickly, f prime x. So it's rational form, so denominator square will be there. So this is x square plus 2x plus 4, that whole square. Then this is constant, again x square plus 2x plus 4, that will keep constant here. Then we will take derivative of numerator. So derivative of numerator x square equals to 2x, and minus 3x derivative is minus 3 and 6 derivative is 0. Okay, it's close. Minus sign. Okay, so what is this? This I'll take numerator, I'll take constant, keep constant x square minus 3x minus 6. Then I'll take derivative of the denominator. So this x square is 2x, and then it is 2x derivative is plus 2 and 4 derivative is 0, constant is 0. That's simple. Okay, now I can simplify it. So this will be remain same. This is x square plus 2x plus 4. Now this one I can expand it. So if I consider this thing, it will be 2x cube. If I multiply first 2, then it is 2 to 4 x square minus 3x square is plus x square. Then 2 into 4 8x minus 6x. 8x minus 6x is plus 2x. And 3 and 4 12, but minus sign, minus 12. Okay, this is the first term. And second term, this one, this product. So it is 2x cube. Then minus 6x square plus 2x square minus 4x square. So you can see quickly we can multiply. Okay, this is minus 2, minus 6 into 2, minus 12x, and 2 into minus 3, minus 6x, minus 12, minus 6, minus 18x, and minus 6 minus 2 is minus 12. That's all. Okay, now we can simplify it further. So this is 2x cube plus x square plus 2x minus 12. This is minus multiplication. Minus 2x cube minus 1 is plus 4x square plus 18x plus 12. Okay, and denominator, this square will be there. So here you will see this is cancelling out, 12 is cancelling out. Okay, so what you will get? This is 4 plus 1 is 5x square. This is 2x plus 18x is 20x upon these things. X square plus 2x plus 4, that square. Okay, so we have got the f dot x. Okay, so what is the f dot x or f prime x? Derivative of this one. This is 5x I can take common. It is x plus 4, and this is your x squared plus 2x plus 4, that's whole square. Now from here, as we know that this value is always more than 0, that we have seen. Denominator is, again it is square term is always there. Okay, so this value could be 0. So when this function f of x should be 0, that we can solve it. What are the solutions? So this x could be 0 or x could be minus 4. So at these two places, the function value will, derivative of this function will be 0. Means we can get maxima or minima at those 2 points. Okay. Now which point is having maxima, which point is having minima, that we need to decide. So for that we will use sign convention. Okay. So I have discussed this kind of problem in my previous videos. So you can go through other videos, you will find lots of interesting ideas there. So what you will do, you will place these values where the derivative is becoming 0, where this is x equal to 0. So I will put another color. So this is the x equals to 0, and this is the point x equals to minus 4. So here I will put one line, vertical line. Here I will put another vertical line. Okay, this is your x. Fine. Now you can see I have said that from 0 to right side, this is your one point. When x is more than 0, this factor is positive, and x plus 0, 4, this is also positive. So both the factors will be positive, and numerator is always positive. Okay, so this side will be positive. For any value right side to this point x equal to 0, the function f dot x will be positive. Then it is alternative. This will be negative, and then this will be positive, right? because within the range x equal to -4 to 0, x is negative but x plus 4 will become positive. That product positive negative will become negative. And when x is less than -4, both the term x and x plus 4 both will become negative. Negative negative multiplication will become positive. Okay, that's simple. So this is about f prime x. F prime x is positive when x is more than 0. F prime x is negative within -4 to 0, and x prime is again positive from -infinity to 0. Okay, so what is the range? This three range I have got it. -infinity to -4. This is the first one. That time what is happening? It is positive. F prime x is positive, means it's an increasing function. Okay, this is first one. And second one is -4 to 0. This range, within this range, this f prime x is negative. That implies it's a decreasing function. Okay, and the last one is 0 to infinity. This entire range, that time f prime x is again positive. That implies it's increasing again. Okay, so I have got this range. Now in the question it is given these few ranges. Okay, so what is the range? So this is your -2 to -1. So it could be here. It is a -2. It's -1. So within this interval, it is negative. So within this interval, that function f prime x, derivative of function is negative. That implies that f of x is decreasing within this interval. So A is correct. F is decreasing with the interval -2 to -1. Then 1 to 2, it could be here to here. It is 1, it is 2. In this range, this is positive. This is positive. That implies f of x is increasing. Okay, so f of x is increasing with the interval 1 to 2. This is also correct. So both A and B are correct. Okay, now we need to find out the range and whether f is on 2 or not. Okay, now try to find out the range. Range means how function value will vary from maximum value to minimum value. Okay, that maxima and minima I need to find out. So I have considered these two, that f prime x or derivative of f of x will be 0 at x equal to 0 and x equals to -4. So at these 2 points I can have maxima or minima. Now you can see that at x equal to -4, function value, derivative of this f of x is changing from plus to minus. What is the meaning? So plus means function is increasing. So here it is a function is increasing. Then after this point x equal to -4, function is decreasing. Means at x equals to -4, it will attain a maxima. Okay, because it will go on increasing somehow and then it will have maxima, then it should decrease like that. That's the function is decreasing. Very similarly, at x equals to -4, you can see left side is negative, means function is decreasing, and it can have some minima, then again it is increasing. So it can have some kind of minima here. So it is minima. So at x equals to 0 it is minima, x equals to plus -4 it is maxima. So I need to find out these two values. Okay, so what is the value f of, so what is the function f of x? Is your x square minus 3x minus 6 upon x square plus 2x plus 4. So what is your f of 0? That easily you can calculate. So if I put zeros everywhere, it will be -6/4 means -3/2. Right? And what is your f of -4? The value that also you can put, it is 16 minus plus 12 minus 6 upon this 4 square is 16, 2 4 is 8, it is minus sign. Okay, it's minus 8 and plus 4. Okay, so what is the value? So this is 28 minus 6, 22. This is your 8 plus 4 is 12. So it is 11 by 6. Okay, so what is the meaning? This is your maxima and this is your minima. Okay, now can I draw the function, total function? Okay, let me draw the whole function. So this is your x and this is the point, okay, x equals to 0, and this is the point x equals to minus 4. So what I have said, that at x equals to minus 4 it is having the maximum value, and that maximum value, suppose here it is 11 by 6, and at x equal to 0 it is having minimum value minus 3 by 2, because f of 0 is minus 3 by 2 and f of minus 4 I have got 11 by 6. Okay, so this is minus 3 by 2, which could be suppose here minus 3 by 2, right? And then I have said that f of infinity is 1, because horizontal asymptote is 1. Similarly, f of minus infinity, this is also 1. Okay, so how is the function then? Now we can easily draw the function. That is not very difficult, because this is the one, suppose one level, this side is, this is the one level. So at this point it will rise. Now this side minus infinity to minus 4, its function is increasing, it will attain the maximum value here. Then within minus 4 to 0 function is decreasing and it will go up to this minimum value, and then again it is go on increasing, and then it will try to get this value, one level. So this value is 1, right? This value is 1. So this is the entire function f of x, how it is varying. So what is the minimum? Minimum value is minus 3 by 2, maximum is 11 by 6. So what is the range? Range is now the minima is minus 3 by 2 and maxima is 11 by 6. But in the question it is given this minus 3 by 2 up to 2, but it can't go up to 2, up to 11 by 6 only. Okay, so this is not correct. The range is not correct. Again, so what is the function given? Function is written as f, that is real to real. So this is your domain, it is given, and this is your codomain, it is mentioned. So codomain is entire real numbers, okay, but range is only the finite range. So range and codomains are not same. It's not same as codomain. So meaning is that we'll find some points on codomain which are not the image of the function. So meaning is that, so this is range is not the codomain, thus it is function is not on 2. So it is not on 2. For on 2, what is the requirement? The range should be same as the codomain. Okay. So here the range is a subset of the codomain, thus it is not on 2. So this C is also not correct. So we have option A correct and option B correct. So A and B, these are correct, and C and D, these two are wrong. So we have solved this problem. I hope this is clear to all of you, and if you have any question, please let me know in the comments below. Okay, I'll be discussing lots of problems like this, and if you enjoyed this video, please press the like button. I'll be discussing lots of videos, so stay tuned. And if you have not subscribed to the channel, you may subscribe to the channel. Thanks for watching.